We're going to get into a pretty important topic as far as this course goes, which is the derivatives of exponential functions. So obviously these come up a lot in many applications. Fortunately, they are probably the easiest derivatives to find. We can see this when we start off with the derivative of just e to the x. The derivative of e to the x is the easiest one to memorize because it's just e to the x. So derivative of e to the x prime is just e to the x, easy. Now, if you change the base, so if a is any base besides 1, which is not really exponential at that point, the derivative of a to the x is a to the x, but now we got to multiply by ln of a, and that is always ln, so we can't use log. It has to be ln. Then these, and I won't spend a lot of time on these because these are just things that we need to do some problems with and memorize the formula more than anything else. Now these we're going to use the topic we talked about in the last video, which is the chain rule. So we have an exponential function where we have a function in the exponent, not just x. And so when we have e to some function, we have to now use the chain rule. So the basic part of the derivative is the same, but now we have to multiply this part by the derivative of the exponent. So let's look at several examples here. Like I think with all of derivatives, seeing the formula is not super helpful, but when you do a lot of problems, that's when it really starts to become second nature, starts to be a little bit easy. I do think derivatives can be easy if you do enough of them, if you get enough practice. So here we have y equals 4 to the 3x. So we're going to have to use a chain rule. So 3x. And so just use the formula that we had. So this would be ln of 4 times 4 to the 3x. Now we have to multiply by the derivative of 3x. So we could write 3x prime here if you like. Don't need to, but maybe in the beginning, when you're getting used to these, you could write this out in a couple of steps. And then we can move this 3 up here. 3 ln of 4 times 4 to the 3x, in parentheses around that if you like. Okay, so it's really just applying the formula. If we have y equals e to the 7x cubed plus 5, if it's an e base, you can always just rewrite that. So e to the 7x cubed plus 5. Now, we have ln of e, I guess. So no matter what the base is, you're going to multiply by ln of the base. But when it's ln of e, then obviously that's just 1, so we don't need to write that. Now we're going to multiply this by the derivative of 7x cubed plus 5. So we'll put this in the front. So the derivative of 7x cubed plus 5 is 21x squared, and then e to the 7x cubed plus 5. And there is our derivative. So not a big deal. Again, this is just like most of the derivatives that we're doing. It's pretty procedural in how you go about figuring out what the derivative is. All right, here we have a product. So we have x squared plus 1 squared, which we'll actually have to use a chain rule for that, times e to the 2x, which technically we have to use a chain rule for that too. So maybe let's get in the habit of writing our u and our v. So we take the derivative of u, we're using the chain rule. So 2x squared plus 1 times the derivative of x squared plus 1, which is 2x. And so that'll give us 4x, x squared plus 1. And then our v is going to be e to the 2x. And then our dv over dx is going to be e to the 2x times the derivative of 2x. So that will be 2e to the 2x. So now we'll bring this down here just so we have plenty of room. So remember the product rule u v prime plus u prime v. And we could write u prime here. We could write v prime here. So u is x squared plus 1 squared. V prime is 2e to the 2x plus u prime. We have 4x x squared plus 1 times v, which is e to the 2x. Maybe not, maybe don't worry too much about simplifying this. You could factor out an e to the 2x, and you could factor out 2, but I don't think it's super important to try to simplify this any more than what it is. We can just leave it like that. All right, let's look at, I think, 2 more. So now we have a quotient rule. So remember this is u of x over v of x, and the derivative is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So let's write out our u and u prime and v prime. So u is e to the x. U prime is e to the x. V is x squared plus 1, and then v prime is 2x. So now let's plug all this in. We have v is x squared plus 1, u prime is e to the x, minus u, which is e to the x, times v prime, which is 2x, all over b squared, which is x squared plus 1 squared. And then we'll see what happens with the top. Actually, it looks like we can factor out an e to the x on top. So we can write e to the x, and then we have x squared minus 2x plus 1. X squared plus 1 squared. This will factor into x minus 1 squared, but that doesn't really help us cancel anything out, so we'll just leave it like that. All right, so combining a couple of things here. We didn't really use a chain rule here, but we did use a quotient rule. We used the exponential rule, exponential derivative. All right, let's look at this one. So this one is a pretty straightforward chain rule with an exponential function. So let's rewrite this with an exponent. So y prime would be, so we're going to use a power rule, and then we got to use a chain rule. So this will be 1/2 e to the 3x plus 1. Subtract 1 from the exponent, so negative 1/2. And now we're going to multiply by the derivative of e to the 3x plus 1. So we have 1/2 e to the 3x plus 1 to the negative 1/2 times e to the 3x times the derivative of 3x. And now we're using the chain rule again. So we're using the chain rule twice here. So we get 1/2 e to the 3x plus 1 to the negative 1/2 times e to the 3x times the derivative of 3x, which is 3. So now let's see if we can simplify this. We have 1/2 times 3, so that's 3/2. E to the 3x, e to the 3x plus 1 to the negative 1/2. Now, usually it's better to write exponents as positive, and we'll also make this a square root. So we'll put this in the denominator. So in the numerator, we have 3e to the 3x. In the denominator, we have the 2. And then we're going to bring this down and make that a positive 1/2, and then we'll just make it a square root as well. So 2 square root e to the 3x plus 1. And there is our derivative. Okay, so go back through if you have trouble with these. We're going to be using derivatives for the rest of the course until maybe the last week or so. So it's critically important. If you want to be successful in this class, you got to be good at taking derivatives. Things like this and the other examples that we have done in this video and the previous videos, you're going to be using all the time. And so you got to make sure that you understand these. This is the most important thing. If you understand limits, that's good. But we don't really use limits a lot for the rest of the course. You got to understand the derivatives. So make sure you practice these and make sure you understand these. If you don't, um, email me. Let's set up a time to meet, and help you get things figured out.